I'm going to do this application two different ways to show you that it is important to clearly define what the unknown is. In this case, we're looking for the unknown is x, which represents the total distance driven by the taxi. The problem says find an equation to describe the following. A taxi fare is $2 for the first mile, and additional miles cost $1.75. The total cost to the passenger was $9. How far does she travel in the taxi? Well, the problem's telling us to let x represent total distance. It's important to write this out so that you see what x is. So if x is the total distance, the first mile that the taxi goes, we're charged $2. The additional miles, each additional mile is being charged $1.75. But we already used up 1 mile for the $2 cost. So therefore, what we have here is $1.75 times x minus 1. There's one less mile for the additional miles. That total, that sum, is equal to $9. The way we solve is to distribute 2 plus 1.75x minus 1.75 equals 9. I'm going to combine the numerical values first. That gives me a 0.25 plus 1.75x equals 9. I'm going to move the 0.25, so leave 1.75x there. And when I move the 0.25, it becomes a negative 0.25, which gives me a total of 875. Now to find what x is, we have to divide both sides by the coefficient. So therefore, x is equal to 8.75 divided by the coefficient of 1.75, and we come up with a value of 5. 5 represents the total miles driven. Now, same problem, but let x be the additional miles. How does that change the setup? Well, the cost for the first mile is $2. The cost for the additional miles is $1.75 times x, which represents the additional miles. That gives me 9. Solving 1.75x equals 9 minus 2, which is 7. Dividing both sides by the coefficient, 7 divided by 1.75 equals 4. Notice x is 4 here, x is 5 up there. If these are the additional miles. So the answer to the question, how many miles were driven, what was the total miles, we have to add one mile to the 4 that we already have. So the final answer for total miles is 4 plus 1, or 5. Let's read this new problem. The officer manager of an election campaign office needs 5,000 postcards in total. Suppose that it costs 2 cents to print a large postcard and 1 cent to print a small postcard. If $87 is allocated for printing postcards, how many of each type of postcard can be printed? Again, let's define what x is. Oh, x is the number of large postcards. X equals the quantity of large postcards. Well, if the total number of postcards is 5,000, that's the total number of cards. Well, what's the quantity of small postcards? Well, X was the quantity of large, 5,000 is total. If I take the quantity of large away from the total, I get the number of small postcards. So now we've clearly defined the quantity. So it costs 2 cents for the large, 0.02x. It costs 1 cent for the small. And the total cost of the total amount we can spend is $87. Now, you may not do the problem this my way, but I like to remove the decimal point because decimals get me into trouble. So because we have 2 decimal places, I'm going to multiply each term by 100. 100 times 0.02 is 2x. 100 times this term is 1 times 5,000 minus x. It's not 100 times each of these, it's 100 times the term. And 100 times 87 is 8,700. That gives me 2x plus 5,000 minus x equals 8,700. I can combine the x terms. That gives me x. I can move the 5,000 from left to right, so it's 8,700 minus 5,000. That gives me an answer of 3,700 large cards. Well, how many small cards do we have? Well, we had 5,000 altogether cards. We take away the quantity of large, and we're going to get an answer of 1,300, which is the small cards. It's very important to define X, write it out so you can see it, and carefully put in the answer.